Okay, welcome to this live stream. We are doing a design review, incremental language development for Wolfram language. It's been a few weeks, I think, since we've done one of these because we've been in the middle of our summer school and other programs. But anyway, we're back and getting ready for the next version of Wolfram language. So first topic, GeoRaster.
Yes, so this is a suggestion from Christopher, and we have Christopher, Shadi, and Brett to discuss this today.
Okay.
So I think the general idea here is to have a more prominent way of exposing the geo information attached to an image. So right now, when we do Geo Image, it has meta information on the ranges of coordinates it covers. But Christopher is suggesting that we create a new head, GeoRaster, to attach that information as a second argument.
So wait a second. So the basic point is you're trying to compute. Okay, remind me, what are the operations? So there's a GeoRaster apply, which is applying things in the appropriate coordinate system, or what?
Right. So this is a generalization of image apply. So we can do operations on the geo image, but taking into account the coordinate information.
Right. Well, okay. So Christopher, I think just rejoined here. Can you introduce this a bit?
Yeah. So I mean, basically, right. I mean, as Jose said, the basic point is just to have geo-referenced images, which is already possible right now through the metadata field of image, which is how like Geo Image works, is it returns geo-referenced images using the metadata field. But sort of the issue is that for operations on geo-referenced images, there are various fields that and also behavior that you need, like that you need to specify when doing operations.
Like image assembly, for example, if you have multiple geo images, they could all be assembled. Like you could have a GeoRaster of a list of GeoRasters, for example, and that could assemble the things in the right places relative to each other.
Sure. Or for another example, let's say you're multiplying together two images in different projections, and you need to say, okay, what's the resulting projection going to be, and what's the resolution going to be, and so on and so on. Right. Or like you could even multiply, two image rasters that are different dimensions because, they're going to be reprojected anyway. So there's a lot of extra stuff you need to provide. Also, there's stuff like you want to be able to have units and so on. So basically, the sort of the general sort of design here, which there are some issues with, is that there's a head GeoRaster which represents georeferenced raster data, and you can sort of, like you do with graph, you can kind of change things like the projections and so on using the function GeoRaster and options. And then the main functions, let me see, I think the main function for sort of doing operations is GeoRaster apply, which basically you give it a function, and then you give it some number of GeoRasters, and then it will, it's like image apply. Now, the main issue here is there's the question of how is the GeoRaster sort of presented to this, to the function that you're applying. So for example, if the function is plus, because you want to add together these two pieces of raster data, then the question is what objects actually get fed into plus. So you might say something like, oh, they could be two images that have already been sort of reprojected. But then the issue is, well, what happens to, for example, the unit data will get destroyed in that case. Or maybe you could do them as quantity arrays and so on. And then that data isn't destroyed, but other things like efficiency, for example, if they're stored in some numeric array, then that sort of gets destroyed by putting them in a quantity array.
You want the operations done on the image, but then you want to reconstitute the metadata afterwards.
Well, right, but for example, let's say the function is times, right? Then, I mean, I guess you could have a special case for times, but it could be some more complicated numerical combination of two images. And the question is, what happens to the units?
I don't know what happens to the units, but what happens at least to the location information is it presumably gets reconstituted afterwards.
Well, right. I mean, I think that this function, given some GeoRasters, it needs to make a decision or be given information in the form of like an option about what the sort of resulting projection dimensions range are going to be.
Okay, but
that just has to be heuristic.
But also, I think one big factor is to understand what's the overlapping region, right, Christopher? Is that where mainly this is coming from? Things like plus or times that you're mentioning really needs to know what parts of the images are overlapping.
No, right. I mean, I think that the default behavior would almost certainly be right to I mean, all these rasters need to have an alpha channel, because basically if you have if you reproject something, odds are it's not going to end up as a rectangle in the new projection. And so you need to have alpha channels for everything. And so, right, I mean, I think that the right solution is to just only, by default, only return the overlap. Although maybe you could imagine having other options for that, but yeah.
Well, but what about, I mean, aren't there other functions that have, like, for example, if it's a times operation, is there a, the extension of the, okay, there are two images, they cross over in one place, but in the other places they're not. The obvious thing to do is to have the identity be, the times be multiplied by an identity element in the place where there is no second image, so to speak. Does that make sense? Is there an analogy of that?
Well, but like the thing is, okay, maybe that works for times, but what if the function is some pure function that's, #1 plus #2 divided by #1 minus #2 or something like that, right? It's like, well, for the plus,
right, it has to be an alpha channel. Well, whatever the alpha channel does. I mean, if one can make it work. In other words, the question is, what is the padding of a geo image that does not extend over the region of the final GeoRaster, so to speak? In other words, if there is a GeoRaster and it is combined with another GeoRaster, and the resulting GeoRaster is presumably always, well, I don't even know what's happening here. Like for this, if there's some other GeoRaster that comes across like this, the combined GeoRaster has a rectangular outer boundary, but then it has some region that is actually populated. Is that correct?
In Geo Image, there is a background option that controls the color that you want to use for those cases.
But Geo Image currently returns image. How is that information propagated into image now?
Well, for example, you can ask for the world in the orthographic projection, which is a circle. So the areas around that region will come up with some.
So GeoProjection orthographic, is that right?
Yes.
Why doesn't that autocomplete? That's a bug.
Mm-hmm. I think it did at the end.
Does all work there, by the way?
I'm thinking it will. I mean, I usually use world, but
it'll probably be a little bit weird though with orthographic.
It didn't. Try world.
Quotes world.
Yes.
Is that a really accurate picture of the? Okay. Okay, so that has white, or is it transparent?
I think it's transparent.
Okay.
Color separate that result.
Right. So this is another issue though, is that so you could you could sort of set it up so that the images that get provided to to the function set of GeoApply are just images with alpha channels. But the problem is that those images, it's very common that you'll have weird numbers of bands, like 8 bands or 2 bands, stuff like that. And so a lot of the image functions get very confused if you give them a 3-band image where the 3rd band is the alpha channel, for example.
So the basic problem is that the images have lists of bands, not associations of bands.
Images, like in general, images are stored as like a single array, right, with many bands in them, and so they have some rank or something. But so it's like, right, you just don't.
In a perfect world, wouldn't it be nice if you could have an association with keys for the different bands in an image, UVA or whatever it is, as opposed to the fact that we're storing it as RGB alpha as 1, 2, 3, 4 elements, if I'm not mistaken.
Yeah, we always just store them as channels. We don't give them names or anything yet.
Right. I mean,
I
for
mean, I
remote
think-
sensing, giving names would be nice.
I agree.
Probably, yeah.
So that's a separate issue. Is could image be generalized so that you could have a collection of layer names or something where you could access the layer name separately, and where this color separate would give an association rather than a list?
Right. Well, I think that right. I mean, there are a couple of features. If you sort of imagined a more generalized image that would be nice for this, I think the features that more generalized image would have is it would have units. It would have, it would have it so you can have arbitrary numbers of bands, and you can do things like tell it band 2 is the alpha channel of my 8 bands or something like that. And then, right, it would probably have named channels, named bands, or whatever you want to call it.
And so because some functions treat the alpha channel specially. What kinds of functions treat the alpha channel specially?
I think the only ones are very explicit: remove alpha channel, and so forth. However, well, all functions do something with alpha channel. Things like binarize first blend the alpha channel into image, and then binarize, and then some functions.
Know which is the alpha channel to be able to do that.
Right.
Yeah.
Okay.
I think there might even be functions like image add might also do some things. I'm not totally sure. I remember though when I was playing with this that I sort of got burned a few times by giving it images and having it not know what the alpha channel was and it doing something really weird.
So yeah, there is a project that we are going to look at how different functions behave when they are fed with images with alpha channel, to make it a little more consistent and document the behavior. So whether we blend or take the alpha from one or the other, or whatever other behavior, or just process the alpha channel in some cases.
So let's take another issue here. So the next issue, so there are two issues that I understand. There's what are the actual geo coordinates, and then there's a projection, but then there's also, let's interpret these quotes color values in terms of some units. Is that right? Is that, Christopher, is that what?
I mean, yeah, sure. I mean, calling them color values. So, right, I mean, often you'll have it so that you'll have a band, and the band, it'll be in some units, but it's not, if you're talking about color values, I don't know if you mean like something like you have a 3-channel image and you say that red means this. That would be very unusual. But just something like if you have 3 bands and you say, these are the units for each band, that would be much more common. But yeah.
What's an example of units that might be given?
I mean, you could have, a very common one is like units of reflectance, which is, just sort of a ratio. But then there's also stuff like,
temperature.
You have some temperature, you have some vegetation index, and that's in whatever weird units it's in. You have a map of primary productivity, and that's in some other weird units, right?
But something like vegetation index, isn't that an index, like a number?
Yeah, but often
go ahead.
Well, I guess vegetation index might, in which case it would probably be some sort of independent unit or something like that. But something like primary productivity has, primary productivity has actual units.
Which is like what? Dollars per hectare or something, or what?
It's like grams of carbon dioxide per area or something like that.
Okay. Jose, sorry.
I was going to say that something very common is to provide elevation profiles as GeoTIFF images, and those the pixels are just elevations, and then you need to know whether those numbers are, I don't know, feet or meters, whatever.
Okay, so question for more generally for images: if we had the possibility of having a units concept for images, so that image data, for example, could, and maybe this is crazy, but is there a desire to have image data have the possibility of getting out a quantity array?
I mean, it seems like okay, so there's a question of like, what is the difference between an image and a numeric array, let's say, right? I mean, the question is, I mean, fundamentally they're the same thing. They're just, one of them's a wrapper around raw arrays or whatever. And so it's sort of like, honestly, I think it would be probably more useful to have something like, a quantity version of numeric array, or some way of having, quantities associated with numeric arrays and being able to have lots of nice operations on numeric arrays, and then, right. I mean, the only issue with that is the fact that you want to be able to do all these operations like binarize and so on, which only know how to work on images.
And the default display is an image display for the geo stuff, typically. I mean, even if you're looking at an ultraviolet band or something, or a primary productivity thing, you typically would want it to display as an image, wouldn't you?
Well, but often you have to like reconstruct it. So I mean, sure, if it's just like an RGB image, then that's easy. But if it's, you have your data and it's got 20 bands, you have to tell it what, I mean, obviously you can have defaults, but like it's gonna have to rejigger the image a little bit to say, this is gonna be the red band, this is gonna be the green band, this is gonna be the blue band, and so on, right?
Yes. Yes. Well, okay. So that processing is another thing that GeoRaster could take care of. That is,
Yeah, I mean,
GeoRaster could have a display function.
Or I mean, it should probably just have an option like graph layout, where it's just an option that changes how it displays.
Right, which says of these different, what is the color? I mean, if you've got 8 bands, how do people typically display that? Do they typically, like convolve that with a purple, another one with a pink, another one with something else? Or how do they do that?
I mean, in the things that I've seen, it's just that they'll just say band 2 is red, band 5 is green, band 6 is blue.
And then they'll ignore the other bands. The other bands won't be displayed.
Yeah.
Will they have a control on the display that says, bring up a different band?
It probably depends on what software you're using, but I mean that might be nice.
Okay, but that's a dynamic. I mean, we don't have that. So Shadi, I mean, right now we have not really been dealing with. I mean, our image functionality has the nice feature that can deal with any depth of image, but
Yes.
but I don't think we've really built that out particularly.
No, but I think one of the things that's been on the wish list for a long time has been functionality, maybe an option in the image construct that can tell us how to do the mapping from n channels to 3 channels. Something like a color mapping matrix or transformation, some option of that sort that says how to do the transform from 12 channels to 3.
Right.
And maybe just, as a wish list item. I mean, it would also be nice if there was, a related option that's like channel 4 is the alpha channel or something like that. Or maybe you could just be embedded in that matrix. But yeah.
Well, so what we're talking about then is something which is some kind of image display function or something, or image display mapping. And then that would, what?
No, I was just maybe like channel mapping or something like
that.
that.
Yeah, channel mapping is better.
And maybe the simplest one would probably be you just give it a list of length 3 where you say 1,3,6, and then the next one is the matrix.
Well, actually something like this where that's the alpha channel there. Or you could presumably give a function.
Well, but the thing is, I think the alpha channel, like in that case, I think you might want the alpha channel to be separate, or maybe you give an association there, because what if you have 2 bands, or what if you have 3 bands? It's band 1, band 2, and alpha channel. Right. And
but I mean, also you could say something like this. You could just have none if you don't want anything mapped to blue.
I guess so. Yeah.
I think that's more explicit, right? Because at the end, you really want to map this to an RGB image.
So Christopher, is it typical that they're using a separate alpha channel, or are there also cases where it zeroes out, the unit for missing type data?
I'm not totally sure what you mean. I mean, usually, like at least in the programs that I've seen that do this like remote sensing stuff, usually they do have an alpha channel, or sometimes they have an alpha channel, and sometimes they just have a missing data number.
Right. I know that I looked at like ozone data, which, the file format dates to like the 70s or whatever, so it's pre-image stuff. And so they're whatever they're measuring, but is represented as an integer between 0 and 1,000 basically. And typical values are several hundreds. But where it's missing, they just are using 0 in their data.
Right. Well, so I mean, okay. So there's some question about how, is there a missing data function, which is what we have for some other machine learning kinds of things? How does that work? But let's just understand here. So we've got things like this. Clearly, in addition to this, we've also got the color map, right? For an image, we've also got the notion of a color map, like CMYK, for example, as David is commenting on our live stream about. Right. What is that? What is the name of the option for that?
Color
color
space?
space.
Okay. So in color space CMYK, what happens? I don't quite understand what happens there. That then means that there are four components for the image, and that will define the display, right?
Correct.
Okay, so it is in fact more complicated. Even, yeah, so the image channel mapping then feeds into the color space. You know, that really might have something that mentions color space, because it is ultimately going to feed it into the color space, is it not? For things beyond the human visible, so to speak. What do you do for color space? In other words, if you've got an 8-channel image, what are you doing? What do you say?
So the default is it says automatic, and then I think I'm not sure exactly how it displays it, but it does display it in some way, which I think is different from just taking the first 4 or taking the first 3.
It's some partitioning of all the channels into the 3 display channels, or 3 RGB channels.
Okay, so this has to be, the image channel mapping has to somehow be convolved with color space to do something sensible. That has to be a combined concept, I think. Do you agree?
I mean, maybe it could even be in the color space option somehow.
Yes, perhaps. That maybe the color space could be something like, you know, something like that, or something. Go ahead, Shodi.
I was gonna say it only makes sense with color space automatic when we don't have the specific named color space.
Why?
Well, no, because I think you want to be able to say both. Channel 1 is red, channel 2 is, channel 6 is green, channel 5 is blue, but you also want to be able to say channel 1 is cyan, channel 2 is magenta, etc.
No, I understand that, but with like I'm saying, with color space settings, we have some named color spaces like CMYK, RGB, LAB, and so forth. But all of those named ones have default displays that we use and we should use. It only makes sense for data that is, or image that doesn't have the explicit color space. So if we have actually multi-channel arbitrary images without an explicit color space, we can go with something like that.
Hey, by the way, I just like to report for somebody there's a bug that we're not bringing up the help raft for in this configuration for color space. It should bring up the help, the I thing here. Somebody got that? I don't have to report that, do I?
Oh, I got it.
Okay. Okay. Anyway, look,
So actually, to a slightly earlier point, I forget exactly who said this, but the thing about missing data values versus alpha channels, one issue is that sometimes different bands will have different coverage, right? So like maybe you have 3 bands, this one is temperature, this one is cloud cover, this one is, I don't know, elevation. And the elevation one is defined everywhere. The cloud cover one though might only be defined, or like the temperature one might only be defined where there are no clouds or something like that.
Yes.
So I'm not sure if that's also something that, to handle. I mean,
right.
Alternatively, you could always get around that by just having multiple GeoRasters, each with their own alpha channel, but it might be nice if there was some missing data thing.
The first question here is units for images. It seems to me that having metadata, having a standardized way to store units for every channel is not completely silly. And that then one could expect to get out. I mean, like, for example, one could even imagine something where you say quantity array of image, and it would bring out the quantity array that is the thing with the units for the image. Is that crazy?
And if the image is unitless, can quantity array still represent that data?
I think so. I mean,
like an intensity.
I think it's just quantity array is just then it just doesn't have any units. I mean, the null quantity is the quantity without units. I don't know what quantity does when it doesn't have units. What does it do?
Well, it converts into a number, and quantity array does the same. But we could invent a dimensionless unit that is preserved.
How does it? I don't even understand how this works. What does it do here? How do I get no unit?
You can say dimensionless, for example, dimensionless unit, I think it's called.
Why doesn't it autocomplete?
I don't know.
It's a bug. Can you report it, please, Addison? Screenshot report.
Yep, I got it.
Okay. All right. Okay.
Right. So I think quantity array does the same. If it's purely dimensionless, we don't want to have two representations of exactly the same thing.
Right. Okay. Fine.
Hold on. I mean, how is so how? I'm not sure exactly how functions like image apply and stuff like that are going to work on images with units, right? So I mean, for example, like first of all, if you somehow did something, you could do something with an if statement where you have different pixels have different units associated with them, in which case that's kind of hopeless, right?
It's hopeless. I think it has to be that a given channel is associated with a particular unit.
But I
That's
guess then
for
the question
sure.
is,
But like binarize of I don't know, with
I
a
understand,
temperature unit, then doesn't make sense.
Right.
If
How
not
does
all
it
of them are.
binarize across RGB? How does it combine the quotes R, quotes G, quotes B units if one's a temperature, one's a carbon dioxide level, one's a something else?
Correct.
How does it?
well, maybe we should just say that that you get one unit for the whole image. You don't get to pick different units for different bands.
I'm
I
not
mean,
sure
because at
that's
some
right.
level, a lot of the time, well,
Look, why not just say binarize is something that operates at the level of the quantity magnitude. It doesn't care about units. Binarize is just not going to pay attention to if one's in centigrade. It's magnificent if one of them's in centigrade, one of them's in Fahrenheit, and you binarize across that, and it should convert them. Well, tough luck, it isn't going to do it. It's just going to treat the thing like quantity magnitude.
Well, for at least single channel images, you definitely want to be able to use the second argument of binarize to give it a quantity, if this were a thing.
Oh, I see. Right. So you say something like binarize the image, and then you say, 40 degrees centigrade or something.
Yeah, but hold on. I mean, the question is though, what operation would you ever do with an image that has different units for the different channels, right? It's like you can imagine something like, here I have the primary productivity in units of whatever, and here I have the temperature. I'm going to divide these, and I'm going to get some coherent thing out. But if I had some image that was, those two things as separate bands, and some other image with some other things as separate bands, it's like, what am I ever going to do to combine these? It's going to produce something coherent, other than just extracting the bands I care about and then doing operations with them.
Fair point. It's probably okay. Let's see. We have various comments on our live stream. Steve Coast here is commenting on several comments here. Might want to define what blue is in the input and output in terms of response curve from the instrument on the bird, as he refers to it, which and what the display does. In other words, the satellite might have a different sensor from the display blue. But we already have that issue, right? That's what color profiles are all about, isn't it?
Although I guess I don't know, I've never used the color profile stuff, but it's often more general. Like for these different satellites, you can get out like, here's the response curve for, radio waves, or for, ultraviolet, and stuff like that. So I don't know, maybe the color profile stuff can handle that.
Well, it's an interesting question, is whether color profile data could be generalized to deal with the remote sensing stuff. I suspect the answer is yes, but because this has device color space, right? And that is the kind of thing that's needed there. Okay, let's see. Might have the. Okay, so Steve is also commenting that the blue band on one satellite might not be the same as the blue band from another satellite. Well, I think that's in the category of, if you really care about that, then if we had named channels, you would be able to say, Landsat 7 blue or something, presumably. How do they designate those? Is that
Well, I think it depends on the format. So like they usually, like the two main formats that I've seen, at least that modern systems use, is there's GeoTIFF and there's HDF5 or HDF4 or Net CDF4 or whatever. And GeoTIFF, I think GeoTIFF supports, like you can't, I don't think GeoTIFF actually really supports like named bands and stuff like that. It's just kind of like, you can have some metadata, like, of course, the georeference, and also the, I think you can have units, but then the actual image is just like a big array. And for example, if channel 1 is in the form of like integer 16, then so is channel 3 and so on. But then there are these things like these other ones like HDF5, which allow you to have more complicated things where, bands are named and they're in different, encodings and stuff like that. But honestly, I think in the second case, I think that I would argue that GeoRaster should represent a GeoTIFF, and that if you have things with different encodings of different units, they should be separate GeoRasters, but whatever.
Fair enough. I mean, look, this is a good example of where named channels would be really nice. Right, rather than just referring to these by number, just being able to name the near infrared channels and so on.
I mean, that could be something that you could just have in GeoRaster, though. I mean, you could just say, you could have your image or your numeric array or whatever's representing the data, and then if you have some function that's sort of like you could have some function for extracting, the coastal channel or something.
Right, but I mean, the other point is for the color profile data, there's ultimately going to be a convolution. Each one of these defines a convolution of some kind, and you're adding those together somehow, and then deconvolving by some kind of device color space thing. It's a little bit complicated, but okay, this is okay. That's a separate issue. Let's talk now about the. I mean, we got to resolve this, and we're not going to get it all resolved today, especially not because I have a cutoff in not too long here. But now what we've got to do. Okay, so
I think an important question here is how much of all of this goes into image itself and how much goes into GeoRaster. Or I was suggesting there that perhaps it should be Geo Image itself. I don't know how much we would break if we try to follow the precedent of GeoGraphics that contains in output a graphics inside. So perhaps Geo Image could contain an image inside and add the geo information.
What do you mean? The Geo Image?
That in the same way that GeoGraphics of input returns a GeoGraphics of graphics plus geo information, Geo Image of input could return a Geo Image of image plus geo information. And so we don't make image to contain all this information. Or perhaps, right now, I think the ideal would be if image can contain geo meta information, and we just make the geo functions look for that geo information.
No, I think that's, I don't like that. I mean, I think that, look, I think there's separate reasons to want to deal with multi-channel images and units and images and so on that are going to be relevant for, units and images could be relevant for some, I don't know, ultrasound image that has, I don't know, pressure values or something like this, and all kinds of reasons why people might use images that have nothing to do with the geo stuff and projections and all those kinds of things. So I think what we were talking about is things that might be useful both in GeoRaster and in image, if that makes sense. But the things for GeoRaster, the specials of GeoRaster are all of the geometry. By the way, let me ask a question. The business about spheres and instead of geographics, the whole business about like geodistance, the things like sphere distance and so on, is that what is the status of that? In other words, non-geo related spherical geometry.
Right. So that's an ILD project on my plate. So I'm
okay.
Yes,
fine.
It's partially developed. Yeah.
But I mean, is that going to lead to a whole other raft of functions? Like, how would you project you want something which is a sphere image somehow?
So at the moment we are, or I'm only working on the computational part and the mathematical part. The same question appears, for example, or will appear with Astro. So how do we represent all the Astro situations, which are also essentially spherical?
Oh, so we're going to need an Astro raster as well.
Right. So there are or visualization functions. So there's a question of how can we funnel all these cases through something in common.
Right. Well, or at least have the same principles for all of them, because they may be somewhat different. I mean, like okay, but let's go back to this. So the one thing that seems fairly clear is that a GeoRaster of, okay, so you could say GeoRaster of some Spain or something, and what do you get out? Do you get something which is a symbolic representation, which is ultimately rendered as an image, so that if you zoomed on it, it would zoom correctly, or what do you get? As opposed to Geo Image, where you just run it once and you get an image back.
So I would argue that GeoRaster, if there was an independent GeoRaster, then it should just represent, like GeoImage, it should just be like, this is the array, these are the bytes, right? Maybe separately, it would be interesting to have some other symbolic wrapper thing that's sort of like basically like some symbolic version of a Geo server, where you can kind of say like, this represents raster data, that's not stored in memory, but where you can sort of request it, and you can request it at a particular resolution and a particular projection, a particular range. But I think that's a different.
Okay, fine. But I mean, there's operations that could be done symbolically on these lazy rasters, so to speak, that haven't yet been rendered with bits, because there are things you could do. The way that things are combined, the transformations and so on, might not even depend on what the actual imagery is.
I was going to say, would something like GeoArray be a better concept?
Well, I don't know. I don't think that's no, because I think that isn't, in the end.
I mean, in the end, that's what, it's sort of what we're looking at, right? I mean, we're looking at, it's multiple layers of array data.
But it's very image oriented.
It is. I just don't like raster in the name. So
yeah. Well, maybe one slightly awkward argument for raster. Actually, I think Jose, you might have mentioned this in email. Would be that you could have it so that GeoImage returns an image. GeoRaster is a GeoRaster object, and you can put a GeoRaster in a GeoGraphics, and it will sort of display beautifully. In that way, you can sort of think of it as a graphics primitive, which is sort of like raster. But I know raster is kind of deprecated, so.
But it's not resolution dependent, is it? I mean, the GeoRaster, you're saying, if you say GeoRaster of Spain, it retrieves the bits at that resolution, and that's all you have.
Right, but you absolutely want to be able to say GeoGraphics of, I don't know, something, maybe the GeoRaster by itself, maybe with some wrapper around it, and then have it display the GeoRaster sort of laid on top of the GeoGraphics.
But will it be recomputed if the GeoGraphics GeoRange is tiny and it's just doing one corner of one field here?
Yeah, then I think it should just cover one corner of one field.
No, I understand that, but the pixels in this GeoRaster, if they have already been retrieved, all you've got there is 2 pixels for the field or whatever.
I mean, potentially you get to, a couple of really big looking rectangles, or distorted rectangles or something.
No, but is that right?
Yeah.
Or should it instead be a thing that says, no, I want to that it's essentially something that is more like.
I think definitely not, because, for example, a large fraction of the time, if you're doing any sort of remote sensing thing, you're probably going to be getting these as geotiffs or something from some random website. You're going to be importing them as GeoRasters. There's no world in which it's going to go back out to this website and get a different resolution.
Okay, all right, but I mean the base map, so to speak, could be at different resolutions.
So I think what we do for that is that GeoStyling has a GeoServer option. So we can style the interior of any polygon, and then GeoGraphics will decide what's the most appropriate resolution from that server.
Fair enough. Okay.
I mean, and if it's something that gets used as a primitive within GeoGraphics, then I'm okay with raster in the name. But if it's something that does stuff on its own, then
it can have a display form on its own while still being usable in GeoGraphics.
Right. I mean, this is the thing, though. It's a little bit of a disingenuous thing, because it's like, oh, look, it's a primitive in GeoGraphics. That's why it's called raster. But 95% of the time, it's not a primitive in GeoGraphics, and you're just doing operations on it independently.
Steve is making another point here, which is maybe we should consider some version of one of these things which can have multiple zoom levels of its imagery inside it.
Right. Again, this is sort of this idea about having kind of a lazy thing that's sort of like a symbolic version of a GeoServer, which I think is interesting, but I think it should be different.
Okay. But I mean, this particular issue here, given a GeoRaster, the question is, you've taken that raster. So Geo Image, you can request in any projection you want, correct?
Yes.
You're doing it right here. Okay. The only thing is it doesn't store that projection. So all you have is the bit.
It does. It does, but in meta information. Exactly.
Yeah. Okay. But what we're asking for in GeoRaster is something where it more intelligently can combine, it knows if you've got, so like, just like show, if you've got this thing in Winkle triple and another thing in Mercator, that if you say GeoRaster of the two of them together, it will do the right thing of, using probably the first projection of any of them, just like show does, to make, to do the right thing.
But I think my point is that perhaps if we do it inside GeoGraphics or GeoImage, they can be trying to look for that meta information.
Right, that basically, it's somehow you don't need this wrapper. You could just have it so that when you call GeoRaster apply, or I don't know, whatever functions would exist, that they would just look at the image, look at the metadata and complain if the metadata doesn't exist, right?
I really don't like this thing about hiding the stuff in the metadata. I think it's going to cause us trouble. Because even extracting, how do you extract the metadata? Can you say information of image, geoprojection, for example?
I think you first have to get out the metadata,
right,
and then it's an association.
Yeah, there is an
And
example at the top of the notebook of how does it look. Yeah, there.
Yeah, see, that's kind of messy. I mean, we definitely want to not have that level of arbitrariness in that.
I would also argue that there are probably some functions like binarize or like, I don't know, there's some, or like maybe show, which should probably work on GeoRasters in a very different way from how it would work on an image. And there's sort of it might be a weird thing if just you're sort of confused. I have two images that look identical, and for some reason here show works and here it doesn't, and stuff like that.
Yeah. Well, wait a minute. Does show work on image? No, probably it doesn't. What does image do?
It converts it to graphics, if anything.
I see, and then puts just a graphics wrapper around it, which then means it can be included in graphics, can't it?
Well, actually, I'm not sure show works on images. I think it might actually complain, but
yeah, I'm not sure. I mean, show does that with other things. But
it does. It does work with images well.
Okay.
So if I say,
for example, if you call, I mean, again, there's the fact that we probably want to have quantities with the GeoRasters, and maybe quantity images could be a thing later. I'm not sure, but or for example, if you call times, maybe times should
what
have
is head
some
of percent, Stephen?
What's that?
Head of percent.
Right. Yeah.
No, you can add axes and everything, I guess.
But if, for example, you multiplied together two GeoRasters, I think that there's probably some default thing it could do. I don't know, it picks the first one as the to use its projection, something like that. But the idea that you would multiply together two images with different dimensions, for example, like, I think that's kind of strange if it's just that you're doing this and you just have to know that there's some secret information hidden in the image that makes it okay.
Right. I unfortunately have to go in a few minutes here. We're not even going to finish this first item, sadly. This is what we get for, oh my gosh, there's lots of stuff here. Oh boy, we've got lots of other things to discuss. Well, it's what we get for not having one of these meetings for a few weeks. We haven't had one for a few weeks, have we? Or am I confused?
I think end of June was the last.
Wow. Okay. Well, okay. I see. Area weighted pixel values.
That's just because if you want to do things like make a histogram of the heights of trees, or I don't know, whatever thing you have a raster of, then the projection isn't necessarily an equal area projection. So you technically should be using weighted data. Right.
I mean, that's clearly a very significant reason to have the GeoRaster concept. Yeah, SL8 is commenting. As soon as functions carry, yeah, if the metadata is carrying around important information, we're introducing a new paradigm, which we probably do not want to introduce. Okay, we're not even going to get this item finished, unfortunately. So we have to return to this another time, and then we will get on to other items. But I think we should probably wrap here for now, unless we have just one or two last comments about GeoRaster. No. Okay. All right. Thanks all here, and thanks to people on the live stream, and we'll continue another time.